So we looked at last class. We looked at right ascension and declination frame. And geocentric equatorial frame. Okay. I told you I need you to do one MATLAB assignment. I'll help you with that assignment. Okay. But essentially, what you're trying to do is, given R is equal to
What example is this? 4.1?
4.1. Yeah, I'll do 4.1. Xi, okay, plus yj plus zk, and let's say b is bxi plus byj. Now, what frame is this in? These two, position and velocity. It's geocentric equatorial frame. Okay, so this is typically, it's also called, I might refer to this as ECI frame. Okay, ECI frame is Earth centered inertial. Okay, and typically we are going to use IJK basis. What is the basis for right ascension and declination? You have alpha, right, and delta. Okay, and then you have R. Now, how do you, if you have the same vector R, do you understand this notation? So think about this. I'll again refer you back to that same figure. Okay. So you have this IJK. This is x-axis or I direction. This is j direction or y-axis. This is k direction or z axis. What is this? This is the origin. So if the satellite is here, somewhere here,
Yes.
what is this? What is this vector? If this is a satellite,
That's R.
that's R, yes. This is R, okay? And this is velocity. You got it? We know this direction is the same for right ascension and declination frame and the geocentric equatorial frame. What direction is this? We said this is the vernal, yes.
What is ECI stand for?
Earth centered inertia. Okay. This is the vernal equinox or the Aries direction. Okay. What is all? This is also 0 degree ascension, 0 degree declination, right? Now, how would you? What is the correlation? What is the correlation between this alpha, delta, and this thing? So this R can be expressed as, what is this R and what is this R? This R is simply the distance. You get it? This distance plays a role here as well, right? What is this UR? UR is this direction in general. The unit vector in that direction. Make sense? Now you have to figure out a relationship between this and this. Okay? How do you, if you want to get to this, we looked at this, right? What is this angle? Alpha. Right, ascension. And this angle is delta. And this distance is r. Okay, so you can see the correlation kind of. You can express this position vector r as there is a I component to this, there is a j component to this, there is a k component to this, right? Or in other, what frame was that IJK component? The geocentric equatorial frame. Okay, or you can look at this R, the distance, this alpha, this delta. That is the right ascension and declination frame. You get it? So, what is the correlationship between these two? I'm going to open this. Right. So this is the critical figure. Okay. Is this visible? Here both the frames are, you can see both the frames. Okay. The position of the satellite can be expressed in terms of right ascension declination or the geocentric frame, which is xijk. Alright. Now the relationship, if you break it down, you are is equal to cosine alpha, cosine delta, cosine alpha I plus okay. Do you understand this? How to get this?
Explain
So
it.
this, yeah, I'll explain it. So this thing has x component, y component, z component. Everybody agrees with that?
Yes.
What is this?
Origin.
No.
Oh, the focus.
No.
That's the projection of.
That's the projection of this on this xy plane.
Oh, you talking about the dash line?
Yes.
Oh,
The projection. In other words, what is this?
Position of the satellite in that.
This is the xy component. Does that make sense? Right?
mm,
So if you look at this has the xy component, right? If I what is this? This is, can I say this is R
Cosine alpha. Okay.
You see that? This is R cosine alpha, right? Delta, sorry. This component would have been R sine delta. You get that? If this is R, right? The projection, this would be this is delta. So the adjacent side is R cosine delta. What would x component be? R cosine delta. So this would be R cosine delta, cosine alpha, and this would be R cosine delta, sine alpha. Now,
I don't see. Personally, I don't see that.
okay, you see this as R cosine alpha.
So, which order we using?
So here is your R, okay? Right? The projection is this. This is the projection. Right? This is R, this is delta. So make this a plane. This is that plane.
Okay, so
This is the hypotenuse. This is the adjacent, and this would be the opposite.
So you're using the R that's going to the satellite.
Yes, yes. So this is the position vector R. This is O. Okay. This is that delta. You get it?
which one? On the picture, which one is regular R? Or scalar R? Scalar.
Scalar is this distance. Okay.
So that R cosine delta,
Mm-hmm.
that dash line right there, what is that a projection of?
This R onto this plane.
Okay,
What distance is the dash vertical line?
That is the projection. So there is a. It's like this. Okay. All right. This is your. This is the plane, right? This is your I, J, right? K. Your R is like this. You get it? This is the projection. The projection is this line. You get it? I have taken this plane and projected onto this board. You get it?
Yeah.
This is R, this is delta. This would be R cosine delta, right?
Yes. Did you draw the R cosine alpha one? I don't see how that one.
What is this R?
Because it's like on the plane, X, Y plane.
Hmm?
Can you draw R? Can you do the
Alpha.
yeah?
Yeah, I'll come to that. So you understand this?
Mm-hmm.
This is this R cosine delta.
Right.
Now I'm going to take this plane, XY plane, okay, and project it like this. This is my Y or J. This is my I, and this is my R, or let me do this. I think that's a little confusing. So here is J, this is I, okay, and this is that R cosine delta. Make sense?
Mm-hmm.
Alright? What is this angle? Alpha. What would this side be? It will be R cosine delta cosine alpha. This would be R cosine delta sine alpha.
So that other projection line stroke or calculus, that you don't need to have. You don't have to have that.
Which one? This one?
No, sir. The one in the one with the alpha is.
This one? Yeah, this one?
You don't need to have that.
What?
Yeah, I was just trying to complete this triangle.
I see. I was kind of confused with that.
Okay? You see this?
Yes, sir. Makes sense.
So you see what component is this?
That's your Y, UK.
There's your eye.
That's where you say cosine delta. For the delta angle.
Delta, this is already cosine delta.
That's the first one to figure out.
Oh, okay. So you're saying.
I've just added cosine alpha.
Okay, I got you.
Okay? So this is your.
I see it.
Okay. So this is a relationship between these two frames. Alright? We look at an example.
Will this always be the case for ECI?
ECI to right ascension and declination. This would be the relationship.
Always.
Always. Okay. So what in exam point of view, what you need to do is, I can give you R in terms of ijk or R in terms of alpha and delta. You need to figure out the other one. You got it? I'll do an example quickly. I'm going to erase this. There is a very simple process. You just need to follow that process. If the position vector of ISS is given by minus 5368 minus 5368. find the right ascension and declination. Okay. So the solution or the method for this is, the first step is to calculate. You need to first find R. What is R?
Unit vector times the magnitude.
No, guys. What is R?
Or distance. Distance.
So how do you calculate that?
Magnitude.
Yeah, it's simple. Square root of 5368 square, right? Plus 1784 square plus 3691 square. Can you describe this? What is this?
What do you mean by this?
So you know what ISS is, right? Once you get this R, what is it? If you were to describe it, how do you describe it?
Distance from the center of the earth.
Right, it's a distance between the center of the Earth and the space station, the ISS.
Yeah.
You got it? It's the distance between center of Earth and space station, okay? This is 6754 kilometers. When you're doing this, if you get something like should you be alarmed?
Yeah, because the Earth's radius is like 63 foot. 6,000.
Exactly. So this is some of the checks you need to do yourself. Okay. So if you should always remember that, even if you don't remember, this is RE. It cannot be less than this. Right? Make sense? The first thing you do is calculate this magnitude R, or the distance between that, and then you calculate L, which is
What was that number?
Hmm?
Sorry, what was that number? 630.
6378. So I'll give you this formula. The second step is L is X over R. Okay. M is Y over R. And N is Z over R. Okay. So what is this? Hmm? Okay. This is equal to and this is equal to make sense?
Can you speak on the variables used a little bit?
Yes. So the variables used is, I'll tell you why the variables used. Delta is sine inverse n, and alpha is cosine inverse 1 over cosine delta. if m is greater than 0, or it is 180 or 360 minus cosine inverse 1 over cosine delta if m is less than or equal to 0.
So you explain
Hmm?
Can you explain the alpha part?
So you understand what we are trying to do. Let's first get that. What we are trying to do is we given ijk, so trying to find delta and alpha. Okay. How do you go from this to this? First, calculate r, the magnitude. Calculate these lmn variables. Okay. And then delta is equal to this, alpha is equal to this. All you need to do is substitute.
Oh, it's just the formula that we
Just the
have to
formula,
use.
just the process. Where did this come from? I think that's the question you want to ask, right?
The formula sheet.
But where did this come from? Sandra, any idea?
It looks like we're getting rid of the IJK and the X and the Y.
But where did it come from? R is, what did we say? X I plus yj zk, right? So this is x, y, z. Clear? R is also equal to R, UR, right? We also said UR is
Cosine delta.
cosine delta
Times
cosine alpha I plus
delta times sine alpha J.
cosine delta sine alpha j plus
Sine delta K.
sine delta k, right? So I can now write R as R cosine delta cosine alpha I plus R cosine delta sine alpha j plus R sine delta k. Make sense? Now what you do is compare these two. This R is the same. What do you get from these two? This one, this one. Okay. So what you can write is Z is equal to R sine delta, right? If you need delta, it is Z over R, sorry, sine inverse Z over R. Sine inverse Z over R. Does that make sense?
Well, what is N?
Huh?
Why?
It's Z over R. Just simplifying the process.
Okay.
You don't have to do it if you don't want to do it.
So will we see any other variables for this X of R, Y, Y, Z, R?
Yeah, you can use it, but you have to change this accordingly.
Yeah.
So now you can see that these two are a little bit, you can say that if you compare this, you can say X is equal to R cosine delta cosine alpha, right? So you can say now you want alpha, right? You get it? So you can say X over R into R cosine delta is equal to cosine alpha. What is x over R? M, right?
X over R, in this case is M.
L, sorry. Did I miss something here?
If you're just looking for alpha, you multiply, we'll multiply by that cosine inverse, right?
It is actually, this is L, okay. This is also L. Alright?
So that's what
L. Alright? So here you can write this as L over cosine delta is equal to cosine alpha. This implies alpha is equal to cosine inverse L cosine delta. Okay? Make sense? So you need to be able to do this problem, okay?
Oh, quick question.
Yes.
Can you just recap from this step one this to step?
I'll just finish this, okay? This turns out to be 33.12 and this turns out to be 198.4. Yes.
I just need you to just go through it. Just
Right, you're given R,
yeah.
alright? The first thing you do is when you're asked, write ascension and declination.
Yeah.
You need to first calculate the magnitude.
Understand that.
If you assign these L, M, N variables,
Mm-hmm.
L is x over R. Since you know R, you know x, you can get L.
Okay.
Since you know Y and R, this is Y, this is R, you get M,
Mm-hmm.
this is M. You know Z and you know R, you get this is N. Okay. Delta is essentially sine inverse N. Whatever value you're going to get there, here, you'll get degrees.
Mm-hmm.
And alpha is one of these values. If M is greater than 0, is M greater than 0? M is less than 0, right? So you use this formula to get.
Okay.
Okay?
And which one is right ascension and which one is
This is the right ascension, alpha.
okay.
This is the declination,
Okay.
delta. Alright? Alright, let me distribute your exams.